सब पीपल कैसे हो भाइयों? वापस हम आ चुके हैं। वैसे मेरा आने का कोई मन नहीं था, सच बता रहा हूँ। मेरा पंखा अभी तक ठीक नहीं हुआ है। मेरे को लगा था आज ठीक हो जाएगा, और मामा मेरे आलसी हैं। सुनने ले, जो छोड़, जो भी है भाई, अभी तक हम लोग का ठीक नहीं हुआ। बेसिकली यही है हमारा। इसलिए मैं आज आने को कोई मन नहीं रहा, और मैं गर्मी में बैठ के अपने प्लग के आगे अब स्ट्रीम कर रहा हूँ। वैसे ही भाई बहुत पसीना छूट रहा है, लिटिल मजाक से हट के कह रहा हूँ। लग रहा है जैसे नदी छूट रही है। आज इतना पानी पिया ना मैंने, पीता नहीं हूँ मैं इतना, मतलब बहुत पानी पीता हूँ वैसे यूजुअली कंपेरेटिवली बाकी हो गए, लेकिन फिर भी आज जितना मैं डेली पीता हूँ उससे बहुत ज़्यादा पिया है। 4-5, पता नहीं कितनी बोतल पी ली मैंने। देख ना दो मेरे को, कितनी बोतल पी ली होगी। 3 बोतल तो, 3 नहीं 2 बोतल तो कॉलेज में पी ली है। आने के बाद फिर जो है 1 बोतल, फिर 2 बोतल, 4, फिर यहाँ पे आके आधा बोतल, 4.5 बोतल तक पिया है। और अभी तो बाकी ही है दिन। पानी लेके आता हूँ। वीक 3 है नहीं है, नहीं वीक 4 रन से है।
All
वीक 3
right, this is CS50, and this is already week 3, our 4th, and this week's focus is going to be pretty much entirely on algorithms, which is exactly where we started the course, recall, back in week 0. But in one of those algorithms, recall, involved a certain phone book, first physically and then virtually, and indeed in a phone book, of course, you have all of these names and all of these numbers, presumably alphabetized by first name or last name, and we looked for someone back then, namely John Harvard, some of you might have called or texted even perhaps that number at the time. But recall that among the goals of having that whole conversation about finding John Harvard or anyone in a phone book, digital or otherwise, was to talk about just how good the algorithm was. It sort of went without saying in week 0 that the algorithm has to be correct. Otherwise, what's the point of writing it or implementing it in the first place? But we also talked about design, and can you make a better algorithm by thinking a little harder about it, maybe harnessing some of your intuition and actually speeding things up, as we discussed. So the first algorithm, recall in week 0, 1 page at a time, was perfectly correct but super slow, and we described its slope with this straight line here. And if that phone book had, say, n pages, where n just means number, it was a one-to-one relationship, because if you add more pages, you need more steps. The second algorithm, recall, where I went 2 pages at a time, was twice as fast, so surely better. Potentially incorrect, though, if John Harvard got sandwiched between 2 pages, but we proposed to solve that by just doubling back 1 page if need be. If you pass the J section, maybe hit the K section, and therefore need to go back at least 1 page. And that algorithm was fundamentally better. Its line was fundamentally lower than the first algorithm's one, because of course it takes half as much time to implement that second algorithm, plus like 1 extra step, just to double back. But the third and final algorithm in our very first week together, recall, was that so-called divide and conquer. And today we'll give it a name again, binary search, by implying 2, because we were dividing in half, in half, in half, again and again, and we got this fundamentally different shape, whereby even if we double the size of the phone book next year, I proposed maybe Cambridge and Alston here in Massachusetts merging together, so you go from like 1,000 pages to 2,000 pages. One of you observed that that's not a big deal, because you need just 1 more tear of the phone book. book to actually take a big bite out of that problem and go from 2,000 to 1,000, then to 500, then to 250, and so forth pages in the phone book. So this week is really going to be about implementing algorithms, not only correctly, but also efficiently, and really focusing on design. There won't be much new syntax in C. We'll give you a couple of building blocks that solve concrete problems, but this week is really about taking a breather after the past 2 weeks of fairly new, fairly intensive C code, and just solve some
क्या हो गया? अबे यार वक्त
new, more sophisticated problems together. So let's consider how we can go about solving problems involving data. Like case in point, phone books are a good example insofar as they represent a decent-sized data set that ideally is in fact sorted alphabetically or otherwise. And in the real world, like we are searching for, we are sorting information all of the time. Like odds are within the past hour or so, all of us have used Google or some search engine in some form. How does Google get us search results like that? Well, they've probably used some kind of very clever layout in their server's memory to get us answers really quickly. So we'll begin to think about, especially when data gets big, how we can use this kind of hardware, but and on top of which we'll write software to solve actual problems. So here again is like a little black chip on top of what's otherwise called a circuit board or a logic board inside of our Macs, PCs, and phones. If, though, we abstract this away and just assume that if this big chip here represents like 1 gigabyte of memory, 1 billion bytes, or 8 billion bits, well, surely we can just arbitrarily but consistently number them. Like this is byte 0, this is byte 1, byte 2, dot, 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 byte 1 billion, all the way down here in the bottom. So we can address our memory in this way. So let's forget about the actual hardware there and now talk about what really is going on inside of the computer's memory, borrowing ideas from last week. So if this is just a canvas of memory, each of whose squares represents 1 byte of memory, how can we go about laying out information, be it names or numbers or web pages or anything else? Well, recall that we divvied this memory up into chunks last time, and we called this an array. And what was key about an array was that it was just a bunch of values back to back to back in memory, so-called contiguous. And it wasn't a huge deal last week that these things were contiguous in memory, back to back to back. But this week, it's actually going to really matter because it's because of that layout and because of last week's week 2 that we can actually solve problems efficiently in this week 3. So for instance, here are a whole bunch of numbers, and these numbers are stored in an array. And this array is of size 7, it would seem, because there's 1, 2, 3, 4, 5, 6, 7 numbers in this here array. And of course, you and I can see all of these numbers at a glance with sort of a bird's eye view. But the catch is that computers technically can only look at one location in memory at a time. Now, that's a bit of a white lie because computers are getting so darn sophisticated nowadays that different types, fancier computers, can maybe do multiple things at a time. But for our model today, we'll assume that a computer can indeed only look at one location at a time. So for instance, if you're searching for the number 50 among all of these values here, well, all of us in a split second can kind of spot it over there, third from the right. But a computer is going to have to look for it a little more methodically, more algorithmically, if you will, step by step in order to solve that problem. So a good mental model to have when it comes to what's going on inside of your computer is that these numbers are, yes, in an array, but they might as well be locked up behind closed doors, whereby in order to see each of those values and find one of them, the computer is metaphorically going to have to open up each of those doors one at a time, looking for the number that we actually care about. Now, it turns out we can treat this array of closed doors, gym lockers, if you will, much like an array. So this might be location 0, location 1, location 2, dot, 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 location 6. To be clear, there's 7 doors total, but as always, if you start counting from 0, it's n minus 1, which refers to the rightmost or the last door. So
क्या मैं उस पे पढ़ रहा हूँ तो हवा आता है, उसका क्या फायदा? स्विच बोर्ड वहां है। अकेले तो गर्मी में बैठा हूँ यहाँ, पढ़ने का मन नहीं करता, फिर भी पढ़ना पड़ता है। ओह,
Six instead of 7, but there's
ऐसा है इतना। आज तक मैं कभी मैंने अपने रिजल्ट का वेट नहीं किया जितना मैं अब की बार कर रहा हूँ। कसम से कभी नहीं किया इतना वेट। बहुत वेट कर रहा हूँ भाई अपने रिजल्ट आने का। एक बार आ जाए उसके बाद जो शांति मिलेगी मुझे 6 महीनों के लिए घर से।
indeed a total of 7 doors here, just for parity.
हाँ, उतना लंबा तार थोड़ी है, उतना लंबा तार थोड़ी है।
With the lockers we were able to buy online, you might as well think of these as red doors, behind which are all of those numbers. So if the goal at hand now is to sort of mimic what's going on inside of a computer, I bet we could figure out how to find information among these doors. And this is just a problem to be solved. In the world of computing, this is the problem of searching, not surprisingly. And what does that really mean? Well, if we go back again to week 0, where this is computer science, like this is problem solving, what's the input to this problem? Well, we have an array of 7 doors that might as well be locked up behind these doors, and we want to get as output a Boolean value, like true or false. Yes, the number 50 is here, or no, it is not. So true or false, respectively, will get the job done. And inside of this, of course, is going to be, as always, some kind of algorithm, step-by-step instructions for actually solving this problem. So how, then, would a computer concretely go about searching for numbers behind this door? Well, maybe just for fun, we went ahead here and printed out some Monopoly money, some large version. What does that really mean? Well, if we go back again to week 0, where this seven doors that might as well be locked up, put a Boolean value, like true or false. So true or false, respectively, will get the job done. And inside of this, of course, is going to be, as always, some kind of algorithm, step-by-step instructions for actually solving this problem. So how, then, would a computer concretely go about searching for numbers behind this door? Well, maybe just for fun, we went ahead here and printed out some Monopoly money, some large versions thereof, and suppose we want to find very specifically the number, the dollar amount 50 behind one of these doors. Could we get maybe 1, maybe 2 volunteers to come on up? I saw your hand go up first, second on the end there, and let me look over here behind the camera. Number 2, come on down. Okay, come on over. Or maybe a round of applause to break the ice for these 2. Come on up. And we've got 2 algorithms ahead of you, but come on over here if you want to introduce yourself to the world. Maybe a quick something about each of you.
Hi, I'm Jonathan. I'm a sophomore in Cabot House studying economics.
Wonderful, nice to meet you. And?
Hi, I'm Claire. I'm a junior in Elliott studying economics and TDM.
All right, nice, wonderful. Glad to have you both here. So behind you are 7 doors, and which of you would like to go first? Yeah, okay, so first if you want to come on over here, behind these 7 doors are now dollar amounts, namely all of the available Monopoly dollar amounts. And if we want you to find the number 50, you can go about this in a bunch of ways. Like you could go about just opening random doors, but that's not necessarily very repeatable. That's not very algorithmic, step by step. So let me propose that you do something super simple. Start at the left door and work your way to the right. And just so everyone knows what's going on, go ahead and show the world what number you've pulled out of each of these lockers. And the first locker is 20. That is correct, not 50.
500.
Yes, so incorrect.
10.
10, not correct.
5.
Not correct. 100, not correct. 1, not correct, hopefully. Last door. And a round of applause, if we could, for finding the number.
मेरे को लगा था बीच में दे देगा.
So if you don't mind, before we transition to a better algorithm, because frankly that was pretty bad, but it wasn't incorrect in the sense that he was doing anything wrong. He sort of just had some bad luck. And frankly, if I hadn't sort of led him to that path from left to right, I could have proposed more cleverly that you maybe start from the right and then boom, the problem would have been solved. But in general, if data isn't necessarily cleanly laid out by us humans in this very manipulative approach, like maybe it's going to be at the beginning of the array, maybe it's going to be at the end of the array, you really don't know. So you might as well have one methodical approach step by step and just do it again and again. So I think even though that felt increasingly awkward because you didn't find the 50 till the end, that was kind of as good as you could have done in general. And let me propose before we try a second algorithm, if we take a look at some pseudocode here, I dare say what you implemented with
Linear
my sort of
search,
encouragement was something called linear search, literally walking in a line from left to right. And if we kind of take the fun out of searching for money behind doors, we can make this more algorithmic with pseudocode, English-like code, but written in very terse language. You did, for each door from left to right, if 50 is behind the door, ideally, then you would have returned true. And that's when everyone applauded, of course. Else, if not, you might return false at the very end of this code. So we got lucky, 50 was there, but if you hadn't, you might have decreed, oh no, there's no 50, so I returned false. But notice the indentation here, just to highlight a key detail. I'm only returning false once I'm done with that loop. For instance, if I had poorly implemented this pseudocode like this, indenting that return false and only doing it conditionally if 50 is not behind the door. I know we're putting you on the spot here, but do you want to conjecture why this would be bad if you spot the mistake?
If you put false right after
खत्म
else,
हो
that
जाएगा.
means once we search the first door and we don't find 50, it'll just return false and the program will finish.
Exactly. So this code would indeed be a bad implementation, incorrect, because only if the 50 is behind the first door would it ever work correctly. We would otherwise bail out and return false prematurely. So this version here is indeed correct, but can we do better? Well, the numbers that were behind the doors for
भाई
you,
ये
were
लोग
they in
ना
any particular
actually
order?
क्या कहते
No,
हैं,
they were randomized.
No. So we kind of set you up for failure in that sense.
ये लोग ना बहुत ज्यादा लॉजिकली सोचते हैं. ये चीज मेरे को बड़ा सही लगता है. मेरे क्लास में भाई मेरे को बोलना तो नहीं चाहिए पर बड़े बकवास बच्चे भरे पड़े भयंकर. लॉजिक तो सबको क्या बोलते हैं आजकल नया जो ट्रेंड चलता रहता है पगलू पगलू करके. एक टीचर को पकड़ के बैठे पड़े हैं कि भयंकर उसका जो इतना बेकार तरीके से जो पढ़ा रही है. पढ़ा तो मतलब बहुत बेकार भी नहीं बोलूँगा, बट हाँ बेकार है. एक चीज़ अच्छा मेरे को ये लगा कि वो जो पढ़ाती है लास्ट क्लास उसका एक बार जो टेस्ट ले लेती है, वो बढ़िया लगा मेरे को उसके बारे में. बाकी जो है मेरे को कुछ अच्छा नहीं लगा. पीपीटी गंदा सा है. पढ़ा रही है तो उसका इंग्लिश का बस हिंदी में जो है ट्रांसलेट कर दिया, ऐसा कुछ. एग्जाम्पल्स ठीक ठाक है, क्या बोलूँ. कंपैरिजन वाला हो जाता है ना दिमाग में कि जो मतलब पुराने टीचर्स जैसे पढ़ाते थे उसके कंपैरिजन में मतलब बहुत खराब नहीं है, ऐसा समझो. एक अच्छा टीचर है और एक अच्छा टीचर है जो पांच में से चार चीज में अच्छा है. एक टीचर पांच में से चार चीज में अच्छा है और एक टीचर है जो पांच में से दो चीज में अच्छा है. ठीक है, यही है बस, और कुछ नहीं है. और खराब वाला लाइन तुम्हारा हो जाता है दो के नीचे, अगर दो से कम है तो वो खराब में आ जाता है. अब तुम खुद समझ जाओ मैं क्या कहना चाह रहा हूँ. तुम तो कोई रहा नहीं होगा वैसे. मैं बोलता किससे हूँ, मैं खुद से बातें करता हूँ.
And so if you don't mind, let's
स्ट्रीम
go
में
ahead and
देखता नहीं हूँ, बाद में कभी डाउनलोड करके.
pass the mic over, and secretly behind me a moment ago, Yulia was kindly sorting all of
स्ट्रीम
those
भी
same
मेरे को
dollar
देखने की
amounts
जरूरत है.
behind the doors. And the question at hand now for you is going to be find the number 50. But let's do this a bit like the phone book in week 0, where let's start in the middle. And if you recall from week 0, then let's go left or right accordingly. So what's behind the middle door? And we have
It's 20
20. So now correct, but what do we now know? 50 is in which direction?
to the right.
All right, so to the right. So go to the middle of the right. So that leaves you with these three lockers. In that middle door now,
It's 100.
100. So too big. So what do you now know?
It's going to be to the left.
Has to be logically, if it's there at all, in between those two. And now we get your round of applause much faster
50.
than before.
इन लोगों ने फिर से reset मार दिया.
So this then, if I can step over here before we give you a parting gift, this is where we left things off a moment ago. And in linear search, line from left to right, we checked each door. But just to
बाइनरी
make
के
things
लिए
a
तेरे
little
को जो
geekier
पहले
now and
से
a
एक
bit more
सॉर्टेड होना चाहिए,
quantitative
ये
in
भी
nature,
है.
that really is the same thing as slapping numbers on this problem, whereby the first door we're going to call 0. The last door we're going to call n minus 1 if we start to treat these lockers not as physical objects, but as arrays instead. So in that same spirit, let me propose that when we found the number 50 this time, we took a fundamentally different approach, just like week 0 when we did divide and conquer, aka binary search. Binary implying we split the problem in two, and two, and two by going left or right each time, and the pseudocode that you might have arguably just implemented looks a little something like this. If 50 is behind the middle door, well, we got lucky, and we can simply return true right away. But if it's not, if 50 is less than the value at the middle door, we could have gone left, even though you didn't need to. Else, if 50 is greater than that of the middle door, we could search right, and you did do that. But there's a fourth scenario here. And we talked a bit about this in week 0. Do you spot what other scenario I might want to consider?
रुक जा मेरे को कुछ बोलना है. If तेरे क्या बोला वो 50 is behind middle door, return true. If 50 is else if 50 is less than middle door, search left. Else if 50 is greater than middle door. अगर वो उसी के ऊपर
If
हुआ
it's either in the middle or to the left or to the right, what else might happen?
दिखा तो सही.
So what else
दिखा
might
नहीं रहा वो
happen?
सुडो
Was that
कोड
fourth
वापस
scenario?
behind. अगर उसमें है ही नहीं, अगर 50 है ही नहीं.
Yeah. So it might not be there at all, right? I could have really set you up for failure by not putting the 50 there. And in code, though, we need to handle that because I conjectured in week 0, when you don't handle all possible scenarios, that's when the computer crashes or freezes or just something goes awry. So if there are no doors left, you sort of run out of possibilities. Logically, we had better make sure we return false. So before we give you both maybe one final round of applause, wonderfully, Monopoly makes its own Harvard edition for Cambridge, so we have a nice parting gift for both of you today. Thank you both for coming on up. All right. So just to now make that algorithm a bit more quantitative, instead of just saying middle, 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 let's use a bit of array syntax here now too. So this is the same exact pseudocode for that algorithm, binary search. And so the first condition is the same. If no doors left, just return false. But if 50 is behind doors bracket middle, and again, I'm sort of stealing some syntax from last week where we introduced square brackets for arrays, but I'm still using pseudocode. So this isn't C per se, but by doors, I mean the array known as doors. Bracket middle, I mean whatever the middle number is, the middle index is, go there. If you found it behind the doors bracket middle, return true. Else, as we enacted a moment ago, if 50 is less than the middle door, then go ahead and search what? Well, instead of saying search to the left and search to the right, let's make this again more precise today. Search the array of doors from location 0 all the way through location middle minus 1. So what do I mean by that? Here was the middle door, and even though this is not what we did a moment ago, if we were to go left, here's bracket 0, the first door. Here is middle minus 1, because if this is middle, minus 1 is immediately to the left, and this is why this algorithm would indeed have us searching the left half. Equivalently, if 50 is greater than doors bracket middle, then search doors middle plus 1 through doors n minus 1. Well, the end of an array, if 0 indexed, that is, you start counting at 0, this is always n minus 1. If this is middle plus 1 is here, and this is exactly what you just did, searching the right half of those doors. So we have this translation then from sort of the intuitive pseudocode from week 0 into now the more technical expression of arrays and array syntax here this week. And that's something now we'll begin to build on over the course of writing and implementing some of these problems here today. So if we now have algorithms that both solve the same problem, just like in week 0, which of those algorithms was better? The first one, which we called linear search, or the second one, which we called binary search? They're both correct, I would claim. So which is better? Which is better design? 2, and why do you say that? Okay, so 2 is more efficient insofar as the second algorithm, if I'm thinking back, only took 3 steps. She only had to open up 3 of the doors, whereas the first algorithm, linear search, actually took as many as 7 steps. And in fact, we'll see some math underlying this, but it would be nice now if we could really compare the design of, the efficiency of algorithms a little more rigorously than just saying one is better than the other. Let's see if we can slap not some numbers on it, but maybe just some very simple arithmetic or algebraic formulas that allow us to compare 2 algorithms, so that in the real world and in problem sets and in projects in the future, you can sort of make a more quantitative claim as to which approach is indeed better. So when we talk about running time, we literally mean that, like how much time does it take for a program to run, but we don't necessarily count in terms of seconds or ticks of a clock more generally. Instead, we'll try to count the number of operations that an algorithm takes. So for instance, this was a way of analyzing the running time of 3 algorithms way back in week 0. And I did introduce a bit of jargon whereby I was using expressions like n to represent n pages, or n divided by 2 to represent half as many pages. And even though I waved my hand at week 0, log base 2 of n is mathematically how you would represent the idea of dividing something in half, in half, in half, if you start with n pages. So those are 3 formulas, but it turns out that at least 2 of these algorithms from week 0, they're pretty darn similar to one another. Indeed, literally, 2 of these are straight lines, even though the slope is slightly different. The other one is fundamentally curved and therefore different, and indeed we saw better, but let's get out of the business of worrying about maybe constant values, like dividing by 2. We really want to care about when algorithms are sort of fundamentally better than one or the other. So case in point, here are those same 2 algorithms from week 0. This was turning 1 page at a time. This was turning 2 pages at a time. Honestly, if I wanted to speed things up by a factor of 2, why don't I just use a faster Mac? A faster PC, right? Nowadays, I could literally wait like 1 year and next year's computer will be practically twice as fast, it would seem, than the first. And so if we start to try to compare the efficiency of algorithms, it would be nice if they're sort of resilient, those comparisons, to what computer you use to run the code. We want to take a step back and sort of approach things a little more mathematically, but fairly lightweight nonetheless. And so the way a computer scientist typically describes the running time of an
टाइम
algorithm is by
कॉम्प्लेक्सिटी ये
using a
सचिन सर
capital
पढ़ाए थे हम
O
लोग को.
as in a letter, and using it to imply on the order of this many steps. And I actually keep saying as a turn of phrase, wave my hand at a problem. This is sort of the mathematical equivalent of I don't really care about the very precise mathematical formula. It is roughly on the order of this fast or this slow. So what this means is that if you want to describe the running time of this algorithm, this one or this one, syntactically, you literally write on a piece of paper or an essay or the like, big O, and then in parentheses, a
वही तो
little
बोल रहा हूँ
mathematical
भाई,
formula
पुराने
that
टीचर्स
describes how the
क्यों नहीं
running
मिले?
time relates to the size of the problem, just like this XY grid. But it turns out, and I'll claim, we rarely care about denominators if they're just constants like 2 or 3 or 4. All we care about really is the highest ordered term. So whatever the biggest mathematical component is in the expression, the one that really matters as n gets big, that's the one we care about. Because frankly, if n is 2 billion pages, 2 billion in size, well, 1 billion still feels pretty darn slow. If it's going to take that many steps, they might as well be just as slow as each other. But this one here, similarly, if you remember your logarithms, even the base doesn't matter, because you can actually multiply one logarithm by a constant to sort of change the base. And so here, too, we're going to get rid of the specific constant like 2. And here then is how we would describe the running time. And in fact, if you zoom out in your mind's eye and assume that the y-axis is bigger and the x-axis is bigger, if you keep zooming out, zooming out, zooming out, these 2 lines are actually going to pretty much look the same once you've zoomed out far enough. And that's what I mean by they're essentially themselves algorithmically the same. As n gets big, 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 these might as well be the same algorithms. But this one is clearly not. And we claimed in week 0 that this one was better. I claim again today that this one is better. And now we'll begin to slap some formulas on the evaluation of these algorithms so that we have a better sense of what algorithm is better than someone else's. And indeed, in the real world, when you talk about what makes someone a good programmer, what makes someone a good engineer, is sort of having an intuitive sense with practice and with time of how you should write your code so that it maybe has a better running time than some other algorithm. Because when you start working at Google or Microsoft or working in medical data sets or financial data sets and the data is really big and is really big, you probably want to be as efficient as possible. So this here capital O is generally called big O notation. Not particularly technical, but that's indeed what it's called. And here, for instance, is a little chart of very common runtimes. You can use any mathematical expression, but almost always in the context of computing, at least introductory type algorithms, this is kind of the list of possibilities, even though there's infinitely many more. So among the algorithms we've considered thus far, what is the running time of linear search? Well, it's on the order of n, because if there's n doors, like those behind me, in the worst case, consider how many steps might it take me, or take you? Like, it will take n steps, specifically 7, but n in the general case. And so big O is very commonly used when you do want to think about the worst case, because honestly, who really cares if you got lucky and the first door you opened had the number you're looking for? That doesn't really generalize. And, you know, that's not a good argument within Google. Well, hey, once in a while someone will get lucky and will really return them a search result quickly. You want the general case to be fast. And so linear search, really in the worst case, like which customer is going to be the least happy with our Google code? Linear search sort of describes that, an upper bound, so to speak, on how many steps it might take. What about, though, best case running times, or lower bounds on how fast an algorithm might be? Oh, sorry, I should not spoiled this. What's the running time of binary search if the running time of linear search is big O of n? Well, the running time of binary search, by contrast, is going to be log base 2 of n, or more generally, log of n. She could have gotten lucky, our volunteer, by just opening the middle door, and voila, maybe 50 was there. It wasn't. But in the worst case, she only had to look at big O of log n doors in total. And that gave us roughly 3 doors in this case. All right, what if we want to talk about best case running times? Just because it would be nice that in certain situations, how fast can our code actually run? How good is our algorithm? Well, in computing, computer scientists use a capital omega symbol to represent a lower bound. So big O is upper bound, big omega is lower bound, and you can use the same kind of mathematical formula. So here's that little cheat sheet again, but with an omega prefix, which again means lower bound. And same question. In linear search, where you look at the doors left to right, in the best case, how few steps might it take to find a number? I'm seeing just 1, because we could get lucky, and because we go from left to right, could be that we find the number right away. So that's in big omega of 1 in this case, 1 step. Otherwise, how about binary search? What's the lower bound on how quickly we might find a value?
1.
Same thing, right? Because we could just get lucky, because by starting in the middle, it might happen to be right there. So the lower bound on binary search, too, also happens to be in big O of 1, because we just simply get lucky. All right, what if those two are one and the same? One last piece of Greek symbology here. Capital theta here is used when big O and omega are exactly the same thing, which won't always apply, but sometimes an algorithm performs at this rate as well as at this rate, and they're one and the same, depending on the algorithm itself. So here's a little cheat sheet here. And how about linear search? So linear search, in the best case, takes only 1 step. In the worst case, takes as many as n steps. So those are not really one and the same. So theta is really inapplicable here. And binary search, too, this is sort of inapplicable, because in the best case, it might take me 1 step, hence the big omega of 1. But in the worst case, and it's not even that bad, might take me big O of log n. So theta doesn't apply here. But we'll keep an eye out today and see if there aren't certain algorithms that we'll look at that might actually have those values being 1 and the same. And all of this symbology, and that's it really for definitions for now, is what's generally called asymptotic notation. It's notation that you use when talking about the running time of algorithms over time. Like, as the input gets larger and larger and larger, how do these algorithms perform? How can you measure their efficiency? Okay, any questions on big O, omega, or anything prior? We'll come back to theta before long. Any questions? Yeah, in front. Sorry, say again? Is binary search efficient with respect to? Oh, really good question. Is binary search efficient when searching random data, as was the case with our first set of doors? And indeed, those numbers were all over the place. They were not sorted from smallest to largest or largest to smallest. So what is the answer to that? Is binary search efficient when the data is random?
No.
It doesn't work at all. And so
हाँ,
that was sort of the
क्योंकि
hidden
sorted
cost of the two
चाहिए।
algorithms that we acted out. And literally, I had
Binary
Yulia
search में
come up and
sorted
help me.
चाहिए
She did more work to enable us to use binary search because only for the second exercise with the lockers was the data actually sorted. So binary search just does not work if the data is random because you would open a door, see a number, like the number 20, and now you would make a decision whether to go left or right based on the number you've seen. So you simply cannot use binary search when the data is unsorted, aka random. In that case then, how do you sort the data? That's going to be one of the problems we solve ultimately today. Get the data sorted, help Googles of the world sort their data first so that we can find web pages and other things more quickly. Yeah, and back. Oh, any questions? No? All right, so let's actually translate some of this to a little bit of code here. How could we go about implementing something like linear search? Well, let me do this. Let me go over to VS Code here. Let me propose to create a new program called search.c. So I'm going to do code search.c, and in here I'm going to use the CS50 library at the top so I can get input. I'm going to use standardIO.h so I can print stuff out on the screen. I'm going to use int main void because for today I don't really care about command line arguments for this particular program. And let me start with an array of values. Suppose I want to implement in code the idea of these lockers containing those random values initially and implement in C the very first algorithm we enacted with our volunteers, which was searching from left to right. Well, it turns out in C, I can create an array recall by saying I want integers, I want the array to be called numbers, and then inside of square brackets, I can specify how many elements I want. Maybe I want 3, like last week, but in this case, I think I want 7 this week to represent each of these lockers. But it turns out you can initialize an array without even using getInt or the like. You can just specify in empty square brackets that that whole array should equal the following inside of curly braces. So this is one new use of curly braces, but it's a handy trick when you want to create an array that has specific values like 20, 500, 10, 5, 100, 1, and 50, which just happens to be the exact order in which the dollar amounts previously were behind those lockers. So what does this line 6 do at the moment? It creates for me an array of size 7 and initializes it to that sequence of values from left to right. It is not strictly necessary to bother putting 7 there, and it's probably best not to because the computer, specifically the compiler, will figure out how big the array should be based on what you typed inside of those curly braces. And you're just inviting a mistake if you put a number over here that's supposed to match the total over here. At some point, you're probably going to err. All right, so if that gives me then an array of size 7, let me go ahead and ask the user what number do you want to search for, much like I verbalized before. So int n equals get int, and I'll prompt the human for a number as with this kind of prompt. How do I now implement linear search? Well, based on the constructs we explored in week 0 and week 1, we had conditionals and loops and variables and Boolean expressions and the like. What is probably like the feature of a programming language that we're going to need to search from left to right to implement linear search? A for loop probably, or a while loop, but a loop in general. Why? Because I could use like 7 conditionals, and I could say if the numbers bracket 0 equals this value, then return true. Else if numbers bracket 1 equals this number, then return true. But that's not very general purpose. If we're going to have all of these conditionals, let's just have one that asks the same question by just changing some variable. And a for loop is often the paradigm. So for int I equals 0, I is less than 7, I plus plus, and this code alone sort of sets me up to implement what our first volunteer did from left to right with the lockers. What's the question I want to ask? Well, does the array of numbers at the current location I equal the number n that we're actually looking for? So does the number behind the first door, second door, third door actually equal 50? For instance, or whatever's typed in, and if so, let's go ahead and print out something clear like found \n. Else, I don't think I want to do this. Printf not found. So let me for a moment sort of poorly implement this. What have I done wrong with this code? Yeah, in the back. Yeah, I don't want the if in, I want the if inside the for loop, but not the else inside the for loop. Why? Because that would be the equivalent of starting at I equals 0, opening the door, and then concluding I have found or not found the number without even allowing us a chance to keep going, because we're going to spit out sort of unilaterally not found, even though we just haven't found it yet. So I don't think I want to do that, but I think what I can do, for instance, is as per the slide a bit ago, if I, at the end of my loop, get all this way, then I think I can print not found. But I think logically even this might be imperfect. So let me go ahead here and do make search, enter. Seems to have compiled okay, so new syntax errors, /search, enter. What number do I want to search for? I'm going to go ahead and type 50 and hit enter. And still I have a logical bug. It's saying found,
क्योंकि वो
but
कोड जो
also
है
not
टॉप डाउन
found.
चल रहा है ना.
Why? Even though I moved that line of code outside the loop, which is correct, but there's still something wrong here. Yeah. Yeah, the iteration still ends up leading us to this final line. Why? Because we're going to go all the way from 0 to the end of the array again and again and again, hopefully printing out found when we find it. But there's nothing stopping us from then executing line 16 before the program actually ends. But recall last week, we had a solution to this. Even main can return a value. And even though in week 1, it was sort of secretly returning the number 0, unbeknownst to us, it turns out, we now had the ability, as of week 2, to explicitly return a value anywhere in main that we want. And the convention, a little paradoxically, is to return 0 upon success, because that means all is well, and then return anything other than 0, like a positive integer, if anything has gone wrong. And we use positive integers because it could be this thing that goes wrong, this thing, this other thing. Lots more can go wrong than can go right when writing code. So I think what I could do here is after printing found, I could return 0 to signal success, even though the human's not going to see anything different. And down here, I could actually return 1 to signify failure. And recall with the little command trick, I could do $, question mark, and actually see what the value is. But for our purposes, what we really care about is that main returns when we are done solving this problem, either inside of the loop or ultimately outside. So let me try this again. Make search, /search. Let's search for, again, the number 50, enter, and indeed it is found and only found. Let's do this again, /search. Let's search for the number 2, which is not in that array, and I should see and only see
not found
in this case. So this then would be the code for linear search. Any questions on what we just did here? Yeah? A really good question. What if we don't initialize the array? Well, honestly, in programming, a very good answer to that question is just try it out and see what happens. So let me create an array of size 7 with no values inside of it. Let me reopen my terminal window, do make search, and the compiler doesn't seem to mind that. If I go ahead and now do /search, enter, I'll be prompted for a number. I'm going to presume to search for 50, even though I don't know what's in there. Enter. And at least it was not found here. Let me go ahead and try again. Let me search for the number 2, not actually found. Search for the number 1, not actually found. And I could poke around all day long, but it turns out I'm probably just getting lucky here. Why? Well, this loop, no matter what, is going to check 7 locations. But I have not put anything in any of those 7 locations. But recall from last week, we sometimes saw those garbage values, sort of remnants of memory that, of course, exist, but maybe had been used for some other value previously. At the moment, I think I'm just getting lucky that among the first 7 locations in the computer's memory, I just didn't end up with a garbage value 50 or 2 or 1. But if we played this game for a while, I bet I could come up with a number that actually works. And let's see, at the risk of a demo not going according to plan, let me do /search. Let's search for 0. Still not there. Let's search for 3, 4. Okay, we're going to have to do this all day long to actually find the values. There's 4 billion possibilities. But at some point, we would get lucky, and it would say found, but only by chance. So in short, do not do that. Since it is wrong. All right, other questions on the code that we've just written? All right,
भाई
so
जैसे
let's
दिखता है
transition
ना
then to
आग
maybe a
लगा
better
के
version of
कौन
this.
कौन
What if the
कौन
numbers
पूछेगा
are
कौन
actually
पूछेगा पूछो
sorted? And frankly, what if they're
मजा
not
आता है
actually
देख के
numbers at all? Let me go back into this code. Let me throw away the contents of main, and let's do
बढ़िया
something
टीचर
maybe
है
now with
यार
strings instead, just so it's more like searching an actual phone book. So I'm going to create an array of strings called strings, for lack of a better name. And much like a certain game with which you might now be familiar, we might have a string for battleship and boot and cannon and iron and thimble and top hat, though this does vary by country based on which version of Monopoly you actually have. Then let's go ahead and prompt the user for a string S using getString and ask them for a string to search for. And then let's do a for loop again. For int I equals 0, I less than 1, 2, 3, 4, 5, 6 values. I'm hard coding 6, and I don't like that, but we'll come back to that idea in general of figuring out what the length of that array might be. But for now, I'm just going to hard code it, but that's not indeed good practice. I++.
plus
Inside of the for loop, now let me go ahead and do this. If the ith string, or the strings at location I, equals
क्या ढूंढना है
s,
S
then let me go ahead and print out as before, found.
found
Let me not make the same mistake as before, so let me immediately return 0 to signal success. But if we don't find it anywhere in that array, let's go ahead and
printf
print
not
out
found
not found, and then let's go ahead and
return
return 1 just as before. So the only thing that's different now is I'm using strings instead of integers, but I'm otherwise looking for the ith string that might very well have the same value as s, what I have typed in. All right, let me go ahead and open my terminal again. Run make search again. So far, so good. /search. Let's search for maybe the thimble. Enter.
not found
Huh. It's not found. All right, maybe it's too far away. Let's search for again. Battleship. Enter. Not found. How about the top hat? Enter. Not found. And I could do this 3 more times, but I'll claim that it's never going to find any of these strings. Does anyone have a suspicion as to why or how we might
कि वो
solve?
कैरेक्टर्स को चेक कर रहा है स्ट्रिंग्स की
Why is this not working? Yeah. Yeah, well said. So it turns out, and this is super subtle, equals is not how you can compare strings. And we'll see why, in fact, in greater detail next week. But for now, equals works fine for integers, for longs, for chars, and a bunch of other data types as well. But it doesn't actually work for strings. And for today's purposes, it's really because strings can be different lengths. And equals is only going to compare 2 values, but a string might be 3 characters, 4 characters, 5 characters, depending on how many characters I have typed in. Equals is not powerful enough or wise enough to actually solve that problem. However, this is such a common thing to do, like in our phones and on Google and the like, to compare strings that humans have typed in, that there is in fact a solution for this. And so in fact, we'll introduce today another function from the string.h header file
string
that we introduced
compare
last time. Recall that inside of string.h was the
string
declaration
compare
for strlen, S-T-R-L-E-N, which would figure out the length of a string based on the null character and everything we talked about last week. But within the same library, as per CS50's documentation, there's another function called strCmpare, or strcmp for short. And if you were to pull up the documentation for that particular function, you will see that its prototype actually takes 2 strings as input, called S1 and S2, though we could call those any 2 things. But what's noteworthy about this function is that its return value is sort of ternary. It can return one of 3 different things to us. The function can return an int less than 0 if S1 comes before S2. It will return 0 if S1 is the same as S2. And it will return an int greater than 0 if S1 comes after S2. So strCmpare is more powerful than just saying yes or no, these strings are equal. It can actually be used to alphabetize strings as well. Because what it's essentially saying is alphabetically S1 comes before S2, or S1 and S2 are the same, or S1 comes after S2 alphabetically. And alphabetically is a bit of a white lie. It's technically ASCII-betically, because what's being used is the ASCII values. So lowercase characters are going to be treated
गर्मी लग रही है जोड़ की चलो
different from uppercase characters. So we say ASCII-betically because it's literally comparing the ASCII codes. But for now, I'm going to avoid that problem by just using lowercase everywhere. But if I want to use this function, let me go back over to my code here. And instead of doing equals equals, I have to use a function here called stir compare, passing in one string like like strings bracket I, and then the second argument, aka s2, is going to be the string I want to compare against. But I want to check the return value of that function. And again, what value should I check for if I want these things to be equal? So 0 was the operative return value. So what I want to do is this. So this looks at a glance like way more complicated than it really needs to be, but all it's doing is calling a function called stir compare, passing in two strings as input, generally known as S1 and S2, comparing them, and if they are exactly the same character for character, left to right, stir compare per its documentation will return 0. I don't care about less than 0 or greater than 0 because I'm not trying to sort anything. I'm just trying to return true or false, yes or no, we have found this string. So to use that function, just like Stirlang, I need to include string.h at the top. Let me open my terminal window. Let me rerun make search. So far, so good. /search. Now let me search for thimble in the exact same array, crossing my fingers, and voila, now we have found thimble. And just for kicks, I'll do it twice more. Battleship, which failed previously, but this time not. Top hat failed previously, but not. This time I'll search for something like a car, which is not in the array. Enter, and that is in fact not found. So a subtlety, because strings, as we'll soon see all the more, are indeed a bit different from just comparing simple values like integers, chars, and the like. Questions on what we just did with stir compare or searching for this thing linearly in this way? No? All right, well, why don't we graduate to like more of an actual phone book? Right now, I'm just kind of searching for arbitrary strings. Let's make something that's a little more involved, but uses these exact same ideas. Let me go ahead and code up a file called phonebook.c. At the top of the file, I'm going to include those exact same files. So include CS50.h, include standardio.h, include proactively this time string.h. I'm going to create my main function. No need for command line arguments today. Inside of main, I'm going to give myself now two arrays just so we actually have both names and numbers. So for instance, I'm going to do this. An array of string called names. And in that array, I'm going to have three of us. So inside of curly braces, I'll have Yulia, who kindly volunteered earlier as well, me, and how about John Harvard as always, whose number we'll search for. Then let me go ahead and keep track of not just the names in this phone book, but also the numbers. So string, numbers, and then equals, and then the numbers I'm going to put here are going to be, for instance, how about +1 -617 495 1000. Yulia and I will have the same Harvard directory number, so +1 617 495 1000, and then John Harvard will have his old number +1 949 2468-2750, which, just for an Easter egg, you're welcome to text or call sometime. All right, so now I have two parallel arrays, if you will, from left to right that are both mapping names in one array to numbers in the second array. And actually, if I want to keep this thing sorted, that's kind of on me, and I don't really care about that for now, but if I wanted to sort this, notice that I'm actually going to need to move Yulia's name there and move Yulia's number to the end here, but otherwise we still have an array of size 3 for each of names and numbers. Let's go ahead now and search for someone's name and therefore find their number. So let's prompt the user for a string called name using getString and ask them, what name do you want to search for in this phone book? Just like before, let's use linear search to keep it simple. For int I equals 0, I less than 3 this time because there's 3 people involved, I++. And then inside of this for loop, let's do the same correct technique as before. If the return value of stir compare passing in two values. What are the two values I want to pass into stir compare here in order to check if we have found a person's name?
Names
What
I,
could the first one be?
name.
Feel free to just shout it out.
Names I.
What am I searching for? The user has typed in name. But I want to compare it against
Name.
Yeah, I think names bracket I. So like if the ith name is the same thing as the name the human typed in, and I know that because stir compare will return 0 for me, then I can go ahead and say, just as before, found, and just for kicks now, let's go ahead and actually print out what that person's number is, rather than just say found, quote unquote, by outputting numbers bracket I. So this is to say, if we find in names bracket I, the person's name that we're searching for, then go ahead and print out that same person I's number, and so that we don't accidentally say not found later, let's return 0 immediately. Otherwise, down here, let's say not found with no number, of course, and then return 1 to signify error. So if I hide my terminal window, this is sort of a simple implementation of a phone book on like an iPhone or on an Android phone when you're searching for your contacts, top to bottom or left to right. So let me go ahead and run this in my terminal. I'll do make phone book, enter. So far, so good, /phone book. And if I search for John by his name, properly capitalized, enter, I indeed found John Harvard's number to be +1 949 468 2750. This then is correct. What, though, is arguably poorly designed about this program?
I/3 कर
you
दिया वहाँ पे
yourself are still newish to programming.
लेंथ वहाँ पे लेंथ डाल सकते हैं I/3 वहाँ पे ज़्यादा हो सकता है उसकी लेंथ.
Any instincts? What's bad? Yeah.
वहाँ पे लेंथ डाल सकते हैं.
Good. So I don't like that. The fact that I'm using this so-called magic number, which means just hard coding a value that you're trusting is not going to change or that you'll remember to change it, I don't like this. So that's a really good observation. What else might you not like instinctively, even if, again, these concepts are new? And often, yeah.
दिखा तो सही तो कोड.
Yeah, we're again on sort of the honor system here that we have these two arrays, and the onus is on me, the programmer, to make sure that they line up. And case in point, when I manually went back a moment ago and moved Yulia to the end of the names array, I had to remember to move her number to the end of the numbers array, and that just strikes me as very fragile, so to speak, right? It's just too easy for me or a colleague to screw up this code by forgetting that sort of lower level detail. We're just trusting that names and numbers do stay aligned, and they have the exact same number of people in them and the exact same number of numbers in them as well. So we have an opportunity now to sort of do better than this. And besides arrays, which we've already seen do solve a lot of problems by letting us use one variable to store bunches of things, wouldn't it be nice if there was another type of variable that's not int, that's not string, that's not char, that's not float, or any of those that we've seen already? Wouldn't it be nice if there's like a person data type in C, where I can actually create a person in my code, and a person in this world shall have a name and a number? Heck, if we were implementing students, maybe a student could have a name, a number, an email address, a Harvard ID number, or Yale ID number, or the like. You could imagine encapsulating, so to speak, a bunch of different types of data inside of one larger data type. And generally, when we talk about data structures, we mean exactly that, some kind of container for multiple types of data. So a custom data type, if you will. So for instance, if I wanted to create an array of people, wouldn't it be nice if there's a data type called person? So I could use code like this. Give me an array of people, and I don't know how many yet, but give me an array of people, each of which is of type person. So instead of string, instead of int, I'm saying person, and in English, I'm pluralizing the name of the array as, obviously, people instead. But that doesn't exist with C. Like, there are no student data types. There are no people data types. There are no professor data types. Any of these things that you might imagine in the real world don't come with C. All you get are strings and ints and floats and those lower level features. But if we know a person, for our purposes, will have a name and a number, well, why don't we just give them a name and a number, but somehow encapsulate this name and number in a bit of new syntax? And so the new syntax we will introduce today is that of creating your own type that is a structure specifically. And we'll see more of these over the course of the term. And even though this looks a bit cryptic, what this chunk of code here is saying is define a type that is itself a structure inside of which is both a name and a number, which are both strings in this case, and call that whole new structure person. So as soon as the compiler gets to the semicolon, a person data type does now exist. And inside of that data type is two things, a name and a number. Now, as an aside, I deliberately use string here for both name and number. I used string in my code a moment ago for those phone numbers. Why did I use a string instead of an int or even a long for my phone numbers?
क्योंकि वो बहुत
Wasn't
लंबा
actually
हो
a mistake.
जाता है.
Yeah.
इंट आपका जो है वो कितना लेंथ ले
Yeah, like
सकता
the
है, वो डैश
hyphen, the
करके ये सब
country
नहीं लेगा ना.
code, maybe parentheses if you format your number differently. And so a good rule of thumb actually is that even though you and I in the real world might call certain thing numbers, like social security number in the United States, or phone number, or ID number, if there might potentially be other punctuation or symbols in that number, and frankly, more generally, if it would make no intuitive sense to perform math on something you call a number, and I can't think of a scenario where you'd want to perform math on a phone number, you probably should store it instead as a string instead, and use actual integers, actual longs for things that mathematically or computationally make sense to be treated as literal numbers instead. So if I now have this new feature whereby I can define a custom data type in my phone, for my phone book, I think I can implement a brand new version of this program that's going to be a bit more verbose, but it's going to allow me to solve this problem better. So let me go back to VS Code here, and you'll see in this code where we left off. I'm going to go ahead and delete all of this just for now, and I'm going to whip up a slightly better version, I will claim. Outside of my main function, I'm going to do exactly what we just saw on the slide. I'm going to define a structure inside of which is a name of type string and a number of type string, and I'm going to call that whole thing a person. Turns out style 50, and particularly the program we're using underneath the hood, prefers, weirdly, that you put person on the same line as the curly brace, so just FYI if you run style 50 and you see that it moves as such. Inside of main, I'm going to now give myself an array of type person called people of size 3. So still, I'm not going to solve all of today's problems. I still don't like the fact that I'm hard coding a 3, but I just want to demonstrate for today's purposes how we can use this here feature. So I now have an array of 3 people, and each of those people is by definition a person, and a person we now know contains a name and a number. So how do I initialize this array? It's not as simple as just using like get string once. I clearly need to use it twice, but I won't even do that. I'll just hard code the values for demonstration's sake now. Let us update the first person in the people array. So this is week 2 syntax, and set the name of that first person equal to quote unquote David, semicolon. Then in that same person structure, go into their number field and set that equal to +1 617 495 1000 semicolon. So what here is new? Well, of course, people bracket 0 isn't really new. Like we did that last week. If the array is called people and you want the first element, you use bracket 0. But what is new today is this dot operator. Once you've created a structure inside of the computer's memory, if you want to go inside it and access the things that compose it, like name and number, you just use a dot like this. And that means go inside the first person and access their name, set it equal to quote unquote David, and do the same thing now for their number. So even though, yes, this stuff is new here, the only new operator, so to speak, today is really that same dot. All right, let's go ahead and initialize the other 2 people just so we have an array completely defined. People bracket 1 dot name will be John as before. People bracket 1 dot number will be John's number, which was a little different, +1 949 468 2750. And then lastly, people bracket 2 dot name equals quote unquote Yulia, and then people bracket 2 dot number equals the same as mine, +1 617 495 1000. So now, even though this is more of a mouthful, and let your mind wander to the reality that like we could just use a loop to do this a little more cleanly and use getString and make it interactive, but I really just want to demonstrate the type def and the struct and this new dot operator. Let's now search for someone's number. So let's ask the user for a string called name using getString as before, prompting for that name. Then inside of a for loop for int I equals 0, I less than 3. Again, don't love that, but we're focusing on one problem at a time, not this other one. I++. Inside of the for loop now, same as before. If the return value of stir compare, passing in the current person's name and the name that the human just typed in returns a value of 0, then inside of that, let's go ahead and print out found %s \n and plug in people bracket I, but I want to see their number, so I do .number instead. Now I can return 0 for success. Down here I can print out not found to indicate failure, and down here I will return 1. So the only new stuff in this program really is the fact that I have now invented a new data type called person that we can now use in our code, and I'm accessing the individual fields or attributes of that new structure by using this new dot operator, which goes inside of that custom structure. All right, if I didn't screw up, let me go ahead and make this phone book. So far, so good. /phone book, enter, and now if I type in John, enter, I have, in fact, found John's number. And if I go ahead and search for someone else, for instance, like Brian, who's not in the phone book, he, in fact, is not found. Questions, then, on any of this feature via which we've now implemented really something closer to the phone book, albeit using linear search and not binary search.
हर बार हमें एक एक करके जो लेना पड़ेगा लिस्ट में हम एक बार में सब ले रहे थे थोड़ा ज़्यादा बोलिए
You say that a little louder? What if two people have the same name? A corner case, if you will. This code will not work necessarily correctly because it will return to me or print for me
the first
whose
version.
number. Only the first one that it actually finds. So that would be a mistake, and I think we'd need to address that with a bit more complicated code. So solvable, but not for now. A good observation. Other questions on this here code? No? All right, well, let's then tee up an actual solution to this problem, namely, if I want to use binary search, like I can't yet unless I manually sort those arrays, just as Yulia came up earlier and kindly sorted the dollar amounts that were inside of these lockers. Now, she and I kind of coordinated in advance, so she knew exactly what to put in what, but if she were just handed a list of numbers or a stack of papers, each of which was a different denomination of bill, like there's not necessarily obvious how we would go about solving this problem, sorting the values. And after all, even though the phone book that I tore in half in week 0 and the phone book I keep referring to on my phone and yours is presumably sorted by first name or last name so you can find names and numbers quickly, well, how much effort is required in sorting those names and numbers? So case in point, if, for instance, I handed you all of these sheets of paper on which are these different dollar amounts, and they weren't necessarily in any particular order. Instead, I simply hand you a stack of $7 of various denominations like this and say, find me the number like 50, and they're sort of randomly organized. What's the algorithm for finding the number 50? Well, you could just kind of sift through them one at a time, aka linear search, and you'd eventually find it correctly. Or you could take a moment, sort them all, and then much more quickly get me the answer I'm looking for. But would anyone in this room realistically, whether it's 7 pieces of paper or 700 pieces of paper, would you bother sorting them only then to find me the answer? Yes? Yes? No? Would anyone sort them? I mean, I'm kind of setting you up for contradiction. Like, no, it'd be stupid to sort them. Why? Because if you're only being asked one question, find me the 50, why are you wasting time sorting those values in order to find a number that you might as well just sift through quickly and find it by big O of n running time the first place? But suppose I hand you those bills, or suppose I hand you a big database of names and numbers, and I expect that you're going to want to search for someone again and again and again, like your phone. Apple or Google probably are sorting all of those names and numbers. Why? Because you're not going to look up one person's number in the lifetime of your phone. You're probably going to maintain the thing sorted the whole time so that every time you look up someone's name and number, that operation is in fact quite fast. And so that invites the question then, just how efficiently can we actually sort values, and what does it then mean to actually sort these values? Well, the problem of sorting kind of looks like this. If our input and output paradigm is to be believed, the input to the problem would be unsorted data, so like randomly ordered bills or randomly ordered names and numbers. The output, though, we want to be sorted. Specifically, then, if we deal with like an array, here's an array of numbers from 0 through 7, completely unsorted. So same idea as the dollar bills, but I used smaller numbers because it's a bit easier. The goal at hand is to get them from 0 to 7 in increasing order, but for that, we need some algorithm to actually do the sorting, the step-by-step instructions. And it turns out there's going to be bunches of ways we can do that, but maybe just to set the stage before we take a break and have the most delicious Hello Panda chocolate biscuits today, can we get 8 volunteers to come on up and I can offer you an extra snack in the form of these little Mario mushrooms. How about 1, 2? Okay, 3, 4, 5. How about 6? Yes, you, who just put your hand down. 7 on the end there. And let me find someone. How about 8 in the Harvard sweatshirt? All right, come on down. Come on down. And if you 8 volunteers, before we do hellos, if you want to grab a number from Yulia on the side of the stage, those of you with numbers, come on over to the middle of the stage here and line yourself up in this order from left to right. So hopefully we have 1, 2, 3, 4, 5, 6, 7, 8 volunteers. Good. Line yourselves up from left to right in the order you see above you. And Yulia has your numbers for you. All right. Line up here. Okay, line up over here. Number 5, you're over here. Okay, 7, 2, 5, 4, 1, 6, 0, 3. Okay, how about some quick introductions from right to left?
Hi, I'm Becca.
There we go.
Hi, I'm Becca. I'm studying electrical engineering, and I live in Wigglesworth.
Hi, I'm Nitesh, and I just graduated from Northeastern in Masters in Information Systems.
Welcome.
Hi, I'm Owen. I live in Stoughton Hall, and I want to study CS.
Nice.
Hello,
Hi, I'm Maharula. I live in Thayer, and I'm planning to study biomedical engineering.
Nice.
Hi, my name is Atul. I'm in Wigglesworth, and I'm planning to study economics and CS.
Hello, I'm Zorif. I'm from India. I'm studying computer science at Clark University.
Nice. And?
Oh,
Hi, I'm Jasmine. I'm from Shanghai. I live in Thayer, and I plan on studying CS and
भाई वो डर रहा है.
Hi, I'm Ling. I'm from
बेचारा.
China, Shenzhen. I live in Ding.
भाई देखा
Wonderful.
तुमने एक
Let's
चीज
do
नोटिस की?
we
इंडियन
have
बंदे
3
एकदम
attempts here
थोड़े
to sort these
डरे
numbers.
हुए.
Go ahead, sort yourselves from 0 to 7. Go.
बाकी वो लोग नहीं है क्योंकि वो स्टेज पे इतना आते नहीं है ना.
One of you had it easy.
हाँ.
All right, correct. What was their algorithm? What was the algorithm? Could someone explain step by step?
रिप्लेस करने लग गया. रिप्लेस करने लग गया एक एक को जो जिससे ज्यादा वो एक दूसरे से रिप्लेस कर आगे पीछे आ गए.
Okay, so to summarize, those of you who had small numbers generally came this way. Those of you with big numbers generally came that way. And step 3 was, and then they generally figured it out. Okay, so that's correct, and that seems to have been a fairly organic process, but let's take a more of a methodical approach here. Can you reset yourselves to match that same order? So unsort yourselves again, and let me propose that we try a couple of different approaches step by step. So here we have some data that is unsorted, and there's a few different ways I think I could sort of wrap my mind around this. If I want to get the smallest numbers on the left, the biggest numbers on the right, what I think I want to do is maybe do exactly that. Like, let me find the smallest number. So 7 at the moment is the smallest number, but wait a minute, 2 is now the smallest, so I'm going to remember that. Not 5, not 4. 1 is now the smallest number. I'm going to remember that. 6, 0. Oh, 0 is now the smallest number. And 3. So I think, so long as I'm using at least one variable in my mind to keep track of what the smallest number is that I have seen, I can select number 0. And if you don't mind following me here, we can put number 0 at the beginning of this array. But before you move, we could have everyone scooch to the left, right, by taking a step, but that's kind of wasteful, I think, right? That means like a lot of work for a lot of people just to make room for number 0. What would be smarter if I want to put 0 on the left here? Yeah, maybe I can just swap with number 7. Like, you're in the wrong place anyway, so could you please go over there instead where number 0 was, and number 0 come on over here, and now we have begun to sort the list. I haven't solved the problem entirely, but to use the vernacular of week 0, I have taken a bite out of the problem, and frankly, the problem is now smaller, because if 0 is in the right place, now I have only 7 problems remaining instead of 8. So maybe I can do the same algorithm again, a la our familiar loops, and select the next smallest number. So 2 at the moment is the smallest, so I'm going to remember that. 5, 4, 1 is now the smallest. I'm going to remember that. 6, 7, 3. Okay, so 1 is now the smallest. So if you don't mind joining me here, we're not going to move you all, but I think we're going to evict number 2 now and have you go over there instead, thereby swapping the values. Let's do this once more. So I can ignore 0 and 1. So the problem is now size 5. Sorry, I'm off by 1. The problem is now size 6 because we have 8 volunteers and not 7. My apologies. 5 is now the smallest. Oh, 4 is now the smallest. 2 is now the smallest, so I'm going to remember that. But I am still going to keep going because at least for the moment, I'm assuming, sort of small brain here, I only have one variable with which I'm keeping track of numbers. And even though everyone in the audience with your bird's eye view remembers that 2 is obviously now the smallest number, the only way I would remember if 2 is now the smallest is if I were using 1, 2, like multiple variables, but I'm keeping it simple. So I'm only using one variable in this story to keep track of the then smallest value. Now that I know it's 2, let's pull you back out, even though we're undoing something here. 5, let's move you here, so that you two effectively swap. Now I'm going to do it a little faster. So 3, come on out and swap with 4. Now let's go ahead and do 4. Let's go ahead and swap you with 5, selecting the now smallest element. Let's now go ahead and select 5 and swap you with 6. And even though I'm kind of making a bit of a mess here, I'm doing the exact same thing again and again. I just got a little unlucky here. And now 6 and 7, let's go ahead and swap you. And now 7, I'm all done. So I think now they are sorted. And that clearly took way longer, but I think if we just did it like this, like this, like this, it would be not only correct, it would be step-by-step and replicable, and there would be no more sort of magical figured it out at the end. But let's take one final stab at this before we break. If you could go ahead and unsort yourselves to look exactly like that, one final time. And as you do this here, we now have the exact same order as before. So why don't I take different types of bites out of this problem? Because maybe I just think about the problem a little differently. And as we've said since week 0, there are often multiple ways to solve the same problem. And you might think differently from me. So here's maybe how you would think about it. Instead of going back and forth, looking for the next smallest element, let's just solve the problem in front of me, literally. 7 and 2 are the first 2 elements of this list, but they are clearly out of order. So what could I do? Let's just swap 7 and 2. I have fixed at least one problem now. Now let's look at 7 and 5. They are out of order, so let's swap those 2. 7 and 4, you are out of order. Let's swap you 2. 7 and 1, you are out of order. Let's swap you 2. 7 and 6, out of order. Swap you 2. 7 and 0, out of order. Swap you 2. 7 and 3, out of order. Swap you 2. Now, I have improved the situation. Why? What's the most glaring improvement? Who is in the right place?
Not a 7.
Like 7 is in the right place. So even though my algorithm was fundamentally different, I looked at pairs of people adjacently, and I swapped them if and only if they were out of order. I did take a bite out of this problem. I have solved the problem of 7. And so now if I do this again, I can essentially ignore everyone at this end of the list because the biggest number thus far has sort of bubbled up to the top. So I bet I can do the same exact thing by just taking these small bites out of the problem. 2 and 5, you're good. 5 and 4, swap. 5 and 1, swap. 5 and 6, good. 6 and 0, swap. 6 and 3, out of order, swap. I don't have to even look at 7 because I already solved that problem. Now I've taken a second bite out of the problem. Now, even though I'm going back and forth in a different way, I'm focusing more locally on pairs of problems. 2 and 4 are good. 4 and 1, swap. 4 and 5, good. 5 and 0, swap. 5 and 3, swap. Don't have to touch 6 or 7 anymore. So I'm nearing the end here. 2 and 1, swap. 2 and 4, stay. 4 and 0, swap. 4 and 3, swap. Don't have to look at 5, 6, 7 anymore. Now back here. 1, 2, you're good. 2, 0, swap. 2, 3, stay the same. Don't have to look at 4, 5, 6 or 7 anymore. Down over here. 1, 0, swap. Now, I could just stop, but again, I don't have as the computer this luxury of this bird's eye view. I only know if I'm done by going through the full algorithm. So 1 and 2, good. 2 and 3, good. 3 and 4, good. 4 and 5, good. 5 and 6, good. 6 and 7, good. But I'm going to do one last pass because I previously made a swap, and I think what I could do is stop if and only if I make no further swaps. So let's do this again. 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. Now, I would be crazy to repeat that process, because why bother going back and forth across the list if I've done no work? So I think I can conclude that the lists are now sorted. So it turns out that what we have just done is implement 2 different algorithms, 2 of many different algorithms via which you can actually sort values on the screen. After our 10-minute break, complete with cookies, we'll come back, translate this to code and something more algorithmic. But finally, a big round of applause for our volunteers, and come on over this way. See you in 10. All right,
मैं भी स्नैक खा के आ जाता हूँ, और बाय स्नैक मेरा मतलब है खाना। इतना पानी पीने के बाद कैसे मुझे से स्मेल आने लग गया भाई? I'm pretty sure मेरे सांस से स्मेल आ रहा है इतना गर्मी। अंडा खाने अंडे का ही है भाई, मोस्ट प्रोबेबली अंडे का ही है। स्ट्रीम बंद, चल क्या ही बंद करेंगे, कुछ गाना वाना अपना सुनते रहेंगे तो। नानी में खाना दे दीजिए, नानी माँ दे दीजिए ना। ठीक, ब्रेन रैट, कुछ और गाना मन।
$1,000 in cash prizes. Yep.
User can input how big their driveway is, and the backs of your thighs are sticking to your chair. But ask anyone who's actually gotten good at coding, and they'll tell you, once you can get that first project done, you have now actually gotten good at coding, and they'll tell you, once you can get that first project done, you have now ascended from what's known as tutorial hell into the far superior project heaven, which is where all the accomplished developers live and breathe. Just look at Neil.fun. This collection of little mini games was made by a college student practicing coding, and if you look at the first couple of websites he made many years ago, they're pretty basic, something a beginner can make in a few days. But when you look at the newer ones, it's pretty easy to tell that his coding skills got a little bit more advanced. And you can do the exact same thing as long as you put in the time and don't give up, even when business school starts to look real tempting. One big reason you might feel disappointed in yourself when you first start learning to code is because everyone else seems to know way more than you, and they talk about concepts you don't even know exist, as if they're common sense. Sometimes you'll hear your favorite coding YouTubers talking about API calls and weird systems and acronyms and niche technologies and protocols that just make no sense, because none of those things show up in an 8-hour Python for Beginners YouTube tutorial. And although it may seem like some people were born knowing how to set up servers and backend databases and WebSockets and how to create bots out of thin air, it's really just a gradual learning process that takes a long time. You probably won't learn this stuff in school, you probably won't see it in textbooks, and it probably won't get recommended on your YouTube homepage.
Hey, still thinking about joining the 30-day Python using AI bootcamp by AI
नहीं,
for Techies?
I'm
So what if
not
in 30
thinking.
days you could go from knowing
मेरे को join
nothing
ही नहीं
about
करना,
Python?
छोड़ कहीं का।
But you will learn it through projects and Googling and reading
मैं
people's
नाक से
code
बोल रहा हूँ
and
क्या अभी?
copying and pasting other people's code
देखना
until
पड़ेगा
you've
एक बार
created
अच्छे
a
से।
fully functional final product. You won't become a programming
Hopefully,
expert slogging
I'm
through
doing well.
11-hour YouTube tutorials back to back to back. At the same time, one big issue is that everyone tells you to just build projects you're passionate about. But what if you're not passionate about anything? What if you're just coding to pay the bills and your only hobby is watching YouTube? Luckily, there's an easy solution. Hover over the top left menu of this website and click on Projects. Based on whatever language you know or whatever skill you're trying to practice, they have actual, useful projects that you can test your skills with. And the best part is that they give you general guidelines on what to make, how to put your project on GitHub, and where to find help. But unlike most places, they don't just give you the solution. Unlike a YouTube tutorial where you're just watching someone build a project and then copying down every single line of code one by one, this forces you to actually learn. And if you can't find a good project on this website, don't overthink it. Just start. Just do a Google search and pick whatever sounds the most fun. By now, you may be thinking, if tutorial hell is step 1 and project-based heaven is step 2, then what's step 3? Lead Code Limbo. If you don't know, Lead Code is a website where you can practice staring at a computer screen with a coding problem and not understanding anything for weeks in a row. Unless you're applying to a company where you're the firstborn child of the CEO, you're going to have to accept that Lead Code is law. When you're applying to a top tech company, being good at solving Lead Code problems is like a secret handshake between you and your interviewer.
There's a secret handshake that exists in all companies. They want you to be able to jump through a set of hoops to show that you are good enough to be there. And so we don't have like a really good way to gauge how good someone actually is at coding in 20 minutes, 30 minutes, 50 minutes. So instead it's like, hey, you come in here, I'm going to do that secret handshake. You better have done 300 Lead Code problems. You've done 300 Lead Code problems. You walk in, you know how to use arrays, maps, sets, you understand trees. We just know that you can do all the things. Now, is it the best way to test people? Probably not.
There's no best way to grind Lead Code. You can find many roadmaps for Lead Code online, and ideally, you would space it out over at least a few months instead of trying to do 75 problems in a week. But the important thing is, you just have to do it. It might be intimidating to see people on YouTube coding up solutions to lead code hards before you've even finished reading the problem, but it's important to know that everyone once started by solving 2-sum in O of n squared. And if all else fails, you can just tell yourself McDonald's is the new meta. Anyway, if that helped, I'm collecting donations in the form of subscribes to fund the next video.
अबे पर जगना क्यों है सुबह के 4:30 बजे? ये भी तो बताओ, मैं भयंकर सो रहा हूँ रात के 12 बजे 2 बजे. Switch accounts. भाई बाद में देखेंगे.
देखते गाइस. यार तुम खेलोगे? आओ अपन आपस में खेलते हैं. आओ ना गाइस.
क्या?
अगर आप लोग खेलना चाहोगे, ये कस्टम बना रहा हूँ मैं.
छपड़ी वाला. गलती से लग गया. बेकार सा है वो जो उसने बनाया. स्काउट होगा. इमोशनल क्यों हो गए?
स्प्रे एंड सारंग लीव कर रहे. अभी ऑलरेडी कुछ चेंजेस होने स्टार्ट हो गए हैं, बट जो भी डिसीजन प्लीज उसको रेस्पेक्ट करना. किसी दिन सबका चिट्ठा खुलेगा ना भाई, आप लोग खुद शॉक हो जाओगे. हम जिनको आइडियलाइज कर रहे हैं, हम जिनको देखते हैं आ रहे हैं, वो लोग ऐसे इंसान हैं.
प्रिंस ओजी के साथ क्या हुआ ये पता है? इसके साथ बहुत अच्छा हुआ. पूछो क्यों, कैसे?
वो बंदा मेरे को,
अरे रुक जा, साम्राज्य का देखना है मेरे को.
मेरे को इन्फेक्शन भी हुआ था. आई रिमेम्बर.
साम्राज्य का देखना है भयंकर.
सारंग लीव कर.
छोड़ के बच्चे
लीव कर रहे. अभी देयर इज
सारंग का है भाई.
एंड आई कैन नॉट से एनी स्टेटमेंट फिलहाल तो, क्योंकि आपको ये 2 वीक्स में पता चलेगा. एज सच नाउ द कोच एंड द
अच्छा लाइव खेल रहा है. लाइव डुअल ढूंढ रहा है अपना. वाह.
और ऑब्वियसली मेरा एक फाइनल कॉल रहेगा उस चीज़ के बारे में, तो वो मोस्टली अराउंड 1 से 2 वीक लगेगा सेटल डाउन होने में. जो भी होगा अच्छा होगा यार भाई. देखो बस मैं यही बोलूँगा कि जो भी टीम एक्सपार्क के फैंस है, आई नो हम लोग सब डिसअपॉइंटेड है. नॉट जस्ट फैंस, प्लेयर्स, सब लोग बहुत खराब फेज से जा रहे हैं, जहाँ पे सब लोग इमोशनली बहुत हर्ट हुआ है. ये जो इन्होंने इनका जो परफॉर्मेंस, इन लोग जो टूर्नामेंट से बाहर हुए हैं, एवरी सिंगल गाय इज इक्वली डिसअपॉइंटेड. और जो भी डिसीजंस होगा ना गाइस टीम का, मैं कभी नहीं चाहूँ. देखो मेरे लिए टीएक्स में जितने भी आते हैं ना, मेरे लिए भाई है वो. मेरे लिए प्लेयर्स नहीं. यहाँ पे मैंने कभी भी किसी को प्लेयर बना के नहीं रखा है. चाहे वो पुकार था, चाहे वो आदित्य था, चाहे वो ड्रीम्स था. ये तीनों हैं, आज भी ये अपने भाई है. लाइफ टाइम रहेंगे ये. हमारा बाकी और जैसा नहीं है कि यहाँ पे प्लेयर को जैसे लाओ, मजदूरी करवाओ, खराब के लिए निकाल दो. ऐसा नहीं है भाई. बट कैसा होता है यहाँ पे डिसीजन मैं पर्सनली फील करता हूँ कि एज ए टीम लेना चाहिए, कि टीम को जैसे जिस तरीके से खेल के परफॉर्मेंस निकाल पाए उन लोग निकालें. तो अभी आगे इन फ्यूचर जाके ये 2 हफ्ते में आई डोंट नो कितना हार्ड रहेगा मेरे लिए, क्योंकि मुझे पता है मैंने 3 साल कैसे निकाले इस घर में सारे प्लेयर्स के साथ. तो जो भी चेंजेस होंगे, अभी ऑलरेडी कुछ चेंजेस होने स्टार्ट हो गए हैं, तो मेरे लिए तो बहुत ज़्यादा, मतलब बोलते हैं ना दिल पे पत्थर रख के काम करने वाला. अगर मेरे पास उतना पैसा होता, मैं 2 लाइनअप बना के मैं इसके आगे यहीं रख लेता. मैं किसी को जाने ही नहीं देता. मेरे को कोई 2-3 ऐसा बोलते ना कि 2-3 लाइनअप बना दो, तो भाई मैं ड्रीम्स पुकार सबको ले आता वापस. भाई मेरे पास ही साथ रहेंगे एक घर में. इतने क्लोज है मेरे लिए सब. मगर अब क्या करें,
स्काउट भाई कितना वेट करोगे, बस करो स्काउट भाई, है ना. अरे यार हट बे, कहाँ है वो? साम्राज्य बताओ, साम्राज्य का बताओ. साम्राज्य का देखना
नहीं, मेरे को बीजीएस नहीं खेला. लाया था ना. कैसे ये?
अरे
ये देखो हैकर बहन का लंड. ये पता है इसके साथ बहुत अच्छा हुआ. पूछो क्यों, कैसे? ये बहन का लंड.
भाई ये बात बाहर आ जाएगी तो
ये एफएस इंसीडियस कौन है भी मेरे? ट्रॉय. ये देखो हैकर बहन का लंड. ये पता है इसके साथ बहुत अच्छा हुआ. पूछो क्यों, कैसे? ये बहन का लंड जब अल्टीमेट रॉयल आया था ना, तब भाई बोला नहीं मेरे को बीजीएस नहीं खेलना यार, मैं अपना सेल्फ टाइम ले रहा हूँ. पूरा सुबह से रात अल्टीमेट 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 अल्टीमेट. जब बीजीएस का मैच है, एक्वा अवेलेबल नहीं है, तो हम लोग ट्रॉय को बुलाए. भाई मैं तो बीजीएस ये अल्टीमेट रॉयल खेल रहा हूँ, तुम लोग खेलो. और मेरा जो दिमाग खराब हुआ, जो मेरा दिमाग खराब हुआ, बोले खेल बहन के लैंड अल्टीमेट रॉयल, खेल तू, खेल खेल खेल। और ये ले, खेल गया तेरे साथ क्राफ्ट 10। अब पुश कर, रैंक पुश कर रहा था ना ये, उसमें टॉप 100 में जाना था ना इसको, जब साला इंस्टेंट कर्मा मिला इसको। प्रिंस ओजी के साथ क्या हुआ? अब प्रिजन साई जेल, अरे बाप रे बाप, ऐसा तो मेरे को पढ़ने में बुरा लग रहा है। उसका नया ड्रॉप प्रिजन है क्या? नहीं यार, ऐसा मत बोलो। नियो का लाइव देखो, क्या करूं मैं लाइव देख के भाइयों। हम ये सब चीज से दूर रहते हैं। किसी का जो भी हुआ, मैं उसमें क्यों टांग अड़ाऊं? पर जो भी हुआ, मैं प्रिंस का ही पीओवी सुनना चाहूंगा। पर प्रिंस ने तो अपना इंस्टा ही डीएक्टिवेट कर दिया है। आई वाज एक्सपेक्टिंग कि वो कुछ बोलेगा, रिप्लाई देगा, पर उसने अपना इंस्टा ही डीएक्टिवेट कर लिया और वो अभी चुप है। तो साइलेंस,
नानी माँ
साइलेंस
भूख
ऑलवेज गिव्स
लगा
द आंसर,
है।
राइट? बेचारा, बेचारा क्या बोलूं। पर एक
खाना
कुछ
नहीं बना है
मसाला
क्या?
मिला आपको और फिर आप लोग सब चालू।
हाँ नानी माँ,
किसी ने कहा कि मैं सिंपैथी गेन करने के लिए
इनका खाना ही नहीं
या
बना है।
फिर रेलेवेंट होने के लिए ये सब कर रहा।
अबे
तो
हटाओ,
छोड़, वो टॉपिक मैं बाद में कवर करूंगा।
क्या देख रहा हूँ मैं अभी? यार मेरे को लगा मैं भी खाना खाऊंगा, उसके लिए मैं कहाँ गया? क्या
बहुत प्लस है।
वैलोरेंट नहीं खेलेंगे बैंकर,
Have
अभी
you ever
तो
seen
नहीं खेलेंगे, खेलेंगे बाद में कभी स्ट्रीम पे। अभी जब तक देखते हैं।
Now you only need one subscription instead of multiple AI tools. One of my secret weapons
मेरे
is...
जो भाई तुम्हें पता है, आज मैं सुन रहा था अपना गाना। आज मेरे क्लास में क्या हुआ सुनो। तो हम लोग का जो लंच हुआ, हम लोग ने खाना वाना खा लिया मस्त। मैं और मेरा दोस्त पीछे बैठ के जो, अब क्योंकि हम लोगों का भाई पहले पीरियड के बाद कर दिया है, किसी से मिल नहीं सकता मैं, किसी दोस्त से अब नए बनाने पड़ेंगे। ये होता है भाई, मोनोपोली करेंगे अब हम, पुराने दोस्तों को जो है रिप्लेस करेंगे, नए दोस्त बनाएंगे। मजाक कर रहा हूँ, बढ़िया दोस्त है भाई, पर मिल ही नहीं पाऊंगा नेक्स्ट ईयर या नेक्स्ट सेम। हाँ तो अब क्या हुआ, हम लोग पीछे बैठ के आराम से खा पी के खेल वेल रहे थे गेम पे, ऐसे ही खोल के जो है रूम्स खेल रहे होंगे, क्योंकि और क्या ही करेंगे, क्या ही खेलेंगे और ऐसे खेल रहे थे। हाँ वहां पे बैठ के मैं सुन रहा हूँ, आगे में गाना बजा रहा है। कौन सा गाना? पाड़ो। मतलब भयंकर, जो एक दो अच्छे गाने में बचा के रखता हूँ, छुपा के रखता हूँ, लोग छपड़ियों को गाने मिल ही जाते हैं। इंस्टाग्राम पे अभी ट्रेंड कर रहा है शायद वो गाना, इसलिए पाड़ो वाला गाना जो सुन रहा था। भयंकर सारे छपड़ी एकदम आ जाते हैं, अच्छे खासे गाने की बैंड बजा देते हैं। थोड़ा इसको सुनते हैं, ये अभी तक किसी छपड़ी ने नहीं। नहीं ये भी मतलब ठीक है, उसमें चलता है।
I don't know what's happening. She put up her hair.
Sorry.
What the what? 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 No. Huh? Play it back again. Why talk down so deep? Bye bye. Okay, all right. Okay, great singing. Great singing. W China.
कारण नहीं बना
W China.
बंद कर यार अबे यार मेरे को तो बड़ा वो लग रहा है क्या बोलूं नीचा फील हो रहा है जब भी स्पीड की स्ट्रीम देखता हूँ चैनल में भयंकर यहाँ पे लोग लड़ते रहते हैं कि भैया वो हम ना सोच रहे थे कि हमको इस चीज में भी थोड़ा सा कोटा मिल जाता तो हमको प्राइवेट जॉब्स में भी थोड़ा कोटा चाहिए ये हमारा हक है क्या बोले भाई बोला ये क्या है मेरी ड्रेस
भाई कैसे हो
तो मैं बैठ रहे हैं बाद में घुसे ठीक है भयंकर ये देख के तो मेरे को अलग इनसिक्योरिटी जो हो जाती है पैसे होते नहीं है अच्छे खाने के ये लोग अपना दिखाते रहते हैं आई डिड माय लाइफ लॉग्ड इन हेल्दी मीन्स लिविंग अलोन रिप्लाई फीमेल वर्जन ऑफ ओ लेट्स गो कुछ तो नया है एक्सीडेंट में के साथ गाड़ी है भाई बेकार लग रहा है मजाक से हट के कह रहा हूँ
दिल टूट सकता है
तो गॉब्लिन डार्क रिप्लाई अड़क जाए गॉब्लिन ना लगा गॉब्लिन
इतनी शर्म नहीं है माम्बा भाई इतने थोड़ी सी शर्म नहीं है माम्बा भाई मैं तुम लोग को दिखाता हूँ
क्या लिया बाबू आ तो कब आ रहे हैं आपको थोड़ी
अबे यार मैं भी स्ट्रीम करने थोड़ा बीजेस के बाद ही आ जाता छोड़ अगले टूर्नामेंट यार
जिसको ओवररेटेड बोलते हो वो पिछली बार भी टॉप 5 MVP में था इस बार भी है देन गॉब्लिन रिप्लाइड
ऑफिशियल
बीएमपीएस वाला डॉक्यूमेंट्री देख लेना भाई क्या क्रेजी डॉक्यूमेंट्री उसमें तो मतलब कुछ अलग ही बात है भाई वो ना कभी कोई कर पाएगा ना कुछ किसी ने करा है भाई हम लोग कितने पॉइंट की लीड के साथ जीते थे पता है तुम लोग को कितने पॉइंट की लीड थी भैया एमवीपी में 25 किल की लीड से जीता था मैं बीजीएमआई बैन
हटाओ भाई यू गॉट इट कुछ अच्छा दिखाओ जब तक खाना मिलता है तब तक अनप्लग दैट मेरे को आ ही जाता है कॉपीराइट क्लेम कामा मेरे को नहीं सुनना सब छपड़ी फिर पॉपुलर कर देंगे ये सुनता है शायद
I'll honestly tell you about the pros and cons of studying at LP.
आँखों में मेरी तुझे सादगी न दिखे ऐसे कैसे मेरी जाना ये सारी बातें जो दूरी सी रखी थी सुन रहा है अब ज़माना सुबह को आँख खुलते याद तेरा आना ये कैसा माजरा है जाना अदाएं तेरी वो जो दिल को छू गई थी, कभी न कुछ भी मैं कहा ना, कभी ना कुछ भी मैं कहा ना, कभी ना कुछ भी मैं कहा ना।
I'm so dumb भाई, तो क्या मस्त कुछ हो याद आया।
लबों पे मेरे ये कहानी दास्ता तो है पुरानी, साथ हम रहेंगे ये उम्मीद करके बैठे थे, जगा के इस पहाड़ में बजा रहा गिटार में,
मोड़ के जो तू मुझसे यूं चली, मिल गया मुझे बहाना, वो सारे वक्त जो अधूरी सी रही थी,
सुन रहा है अब ज़माना,
सुनेगा अब ये ज़माना, सुनेगा अब ये ज़माना, सुनेगा। सुनेगा अब ये ज़माना। नया गाना डाला, वो भी सुन के देखते हैं। चल, ये कौन सा है? अंडररेटेड आर्टिस्ट को देखते हैं। आ जाओ जाओ। भाई दोनों एकदम से ध्यान लग रहा है जैसे दो ठो गिटार बजा रहा है। मजाक से कह रहा हूँ, दो गिटार बजने का साउंड आ रहा था। हाँ, कॉपीराइट मिलना ही है तो अच्छे से ले लेते हैं।
ले आ गया फिर तेरे दरवाजे के, बरसात से बचने का और बहाना न मिला, बाहें तेरी घर सी लगी और इस दिल को कोई ठिकाना न मिला। पारो मेरी पारो, इशारों इशारों में बात समझ लेना, दिल के टुकड़े हजारों बिखरने से पहले आज पकड़ लेना, कि शराबे खत्म दिए सारे जख्म तेरे भर न सके सोनिया, होना रातें खत्म के सुला दे सनम मुझे बाहों में मेरा, एक जान गई एक जाती नहीं, एक और सितम ना कर, जिसे पाना था उसे खो बैठे ये काफी नहीं है क्या। के अब कुछ होश नहीं है, तू मुझको पिला देगी क्या? मैं पी कर जो भी कहूँगा तू सुबह बुला देगी क्या? तू बाहों में रख ले 2 पल, फिर चाहे दूर हटा दे, मैं गोद में रख लूं अगर सर, तू मुझको सुला देगी क्या? जाती नहीं तेरी याद कसम से, दिल का भरम है तू, बाकी नहीं अब कोई शर्म, जाना एक धर्म है तू, जो कहती थी मत पियो ना मेरी जान जहर है ये, उसे देखता हूँ कि गैर छुए अब और जहर क्या पीऊं। बहुत अच्छा इसका सेटिंग था, पता है, जो जैसे वीडियो होगा पूरा बारिश हो रहा है, बगल में कार है, हेडलाइट जल रहा है, ब्लैक जो भी कुर्ता है क्या बोलते पता नहीं, लोफर्स, एक चेयर बीच में, दारू पी रहा है एंकर, बोतल में से जो जब वो ड्रिंक कर रहा है तो उसमें जो बबल्स फॉर्म हो रहे हैं, काफी अच्छा सेटिंग था भाई, सिनेमैटिक था पूरा। There are few people getting good at doing our stuff भाई। तो पता है क्या, जब तुम ओ फाइनली दे दिया, लेकिन अब एक 2 मिनट 3 मिनट की जो ट्यूटोरियल्स डालता है, ये ट्यूटोरियल्स भी क्या ही देखूंगा मैं, कोई ट्यूटोरियल है में नहीं फंसना किसी भी चीज़ में। थोड़ा स्टार्टिंग कर दिया करूँगा। तो मैं कहाँ था? देखो, अगर जब चीज़ें जो एक्सेसिबल हो जाती है ना बहुत सारे लोगों के लिए, जैसे एकदम मल्टी, ऐसा समझ लो जैसे कल को जैसे क्रिएटिंग रील्स भाई, जब एकदम पूरा एक्सेसिबल हो जाता है पूरी लार्ज अमाउंट ऑफ ऑडियंस पे, तो मैक्सिमम तो बेसिकली छपड़ी वीडियोस ही तुम्हें मिलने वाले हैं, ठीक है, जो भी बनाते हैं। पर अब क्योंकि वो बहुत सारे लोगों के पास जो है एक्सेस है उस चीज़ का, तो उसमें बहुत सारे तो नहीं, बट कंपेरेटिवली तुमको पहले जैसे कुछ लिमिटेड में जितना मिल रहा था उससे ज़्यादा, बहुत ज़्यादा ऐसे जो है तुम्हें क्रिएटिव रील्स भी मिलेगी, सिर्फ क्रिएटिव नहीं, बढ़िया रील्स। मैं पता नहीं क्या कहता हूँ। 5 दिन के बाद इसने डाले ही नहीं क्या? ओ भाई तुम डेली अच्छा डालता है, मैं सोचा डेली डालता था, अचानक से क्या हुआ?
गुड मॉर्निंग गाइस, वेलकम बैक टू अनदर व्लॉग। आई होप यू आर डूइंग रियली वेल। मुझे देख रहे हो तो बढ़िया रहा करो यार, जिंदगी में क्या कर।
मैं रखूंगा, छोड़ो।
12 साल स्कूल में और
Oh,
4
but I'm
साल
still
इंजीनियरिंग।
jobless. The dark side of
12 साल
Indian
स्कूल में
education
और 4
system.
साल इंजीनियरिंग में। हर साल मैंने अपनी क्लास में टॉप किया है, लेकिन फिर भी आज मेरे पास कोई जॉब नहीं है। 10th में मेरा नाम मेरिट लिस्ट में आया था। ये मेरा रिजल्ट है।
दिखा भाई।
हिंदी में 90, इंग्लिश में 96, संस्कृत में 96, मैथमेटिक्स में 98, साइंस में 98, सोशल साइंस में 96।
भाई मेरे तो 85 आए थे ओवरऑल, बेस्ट ऑफ 5 को मिला के बोलूँ तो।
मुझे आज भी याद है, उस दिन पापा अखबार लेके आए थे घर पे, उसमें मेरा और उनका दोनों का नाम छपा था, और वो मम्मी को बता रहे थे।
भाई क्या देख रहा हूँ मैं, भयंकर डिप्रेशन में जाऊंगा मैं।
Alright guys, you guys ready to have a night?
आज खाना नहीं मिलने वाला मेरे को लगता है, मैं भयंकर तब से जो इसको होल्ड पे करके बैठा हूँ कि अभी खाना मिलेगा, अभी खाना मिलेगा, अभी बस मिलने ही वाला है खाना। ऐसे होता नहीं है वो गैम्बलिंग वाला, जो एडिक्शन जैसे लगता है कि नहीं अगले ही मिनट तो अब मैं जीतने वाला हूँ, ठीक है। ओह ये सेक्स एजुकेशन देखा है किसी ने?
इस वीडियो में मेरे पास तो दोस्तों 2030
यानी क्या क्या दिखा मेरे को मत दिखाओ अभी सेल्फ इम्प्रूवमेंट बहुत कर दी मैंने मेरे को दिखाओ ब्रेन रॉट नहीं देखना है करो तो ये रहा ये तो कुछ और ही था बोला ये वो लेट्स गो ये वुड्स ओके ये डाल 40 मिनट की वीडियो इसने सही में ये डाला भाई कुछ नहीं होने वाला मैं कह रहा हूँ
Let's get this thing started. I'm fresh out.
का तुम मुझे रोड मैप मत दो मेरे पास अभी कुछ स्किल ही नहीं है तो रोड मैप देख के क्या करूँगा मैं जॉब लेने की ओ भाई
So you want to be a polymath, a master of
Yeah.
all trades,
Oh,
a
master
person who
of
can
all.
design like an artist, build like an engineer, and strategize like a CEO.
No, sorry, I'm a jack of all trades, master of none. तो रील में आता है ये लड़का रील में आता पता है ऐसे रैंडम इसकी रील आती है मेरे को स्ट्रीम पे क्या क्या दिखने को मिल रहा है
This is a reaction time test.
How to react faster human
This is a
a global economic powerhouse.
ये भूख तुम ये सब बकवास मत करो ओ बन गया लेट्स गो हाँ lay down
Few weeks back, Machiavellianism.
बाद में देखेंगे छोड़ा
Whenever you dive into anything Spider-Man related, you usually end up revisiting, let's say, the
फिर रुको इसको साइड में करने दो उठा के बंद ओबे जो ठोक के बंद हुआ ऐसे नहीं करना था मेरे को बंद गंदा तरीके से ठोक के बंद हुआ कोई रातें खत्म कोई नहीं सोना इसको थोड़ा देर बंद ही रहने दो मैं आता हूँ फोन में देख लेंगे तब तक मैं तो फोन में देखूंगा खाते खाते और फिर 11 बजे से ऐसे ही 12 बजे सो रहा हूँ भाई मेरी स्लीप शेड्यूल ऐसी फक्ड है तो कुछ नहीं कर सकता मैं 5 बजे उठना पड़ता है मन नहीं करता फिर भी अब तो स्पेशली नहीं करता है जब से छपड़ी टीचर सबको छपड़ी बोलने लग गया हूँ टीचर्स है पर कुछ तो है बेकार टीचर्स है बेसिकली मेरे नज़रों में तो बेकार है भाई पढ़ाने का तरीका मेरे को नहीं पसंद आया मैं जिधर देख रहा हूँ कोई छपड़ी लग रहा है, एक लड़का लगा बंदा अरे फ्लैश बंदी खुद में छपड़ी अभी भी लाइव है। मारेगा भाई, आईक्यू से उल्टे मत मारो। नहीं मारा। अबे बस बस तो कॉमन है भाई सामने देते हैं स्किल इशू हो जाता है World battle. लूजर भाई। नहीं है ना एफर्टलेस कंटेंट। हाँ, अभी भी स्ट्रीम हो रहा है क्या? ओबे ले, सबसे क्या मतलब इसी के ऊपर बैठा हुआ है वो? हैं? ओबे भाई, मेरे को पता भी नहीं था भाई। मैं सीधा सीधा बता देता हूँ, मैं इसको कल कंटिन्यू करने वाला हूँ। सिंपल रीज़न, मैं थक चुका हूँ, मेरा दिमाग थक चुका है। मैंने बोलता कि मैं कर लूँगा अभी, पर चांसेस बहुत कम है, क्योंकि मैं क्या बोल रहा हूँ, मेरा दिमाग थक चुका है और मैं गर्मी में और नहीं बैठ सकता अब। खाया भी मैंने गर्मी में ही है, समझ रहे हो? ठीक है, चलते हैं, कल मिलते हैं, उसको कंटिन्यू करेंगे। और मेरे को समझ आना चाहिए ना, मेन तो वो है। ऑब्वियसली लो फेट कंटेंट है जो भी मैं बना रहा हूँ, कुछ तो कर नहीं रहा हूँ मैं, लिटरल बस स्ट्रीम खोल देता हूँ, जो मन करता है करते रहता हूँ। पढ़ना रहता है मोस्टली, तो वही पढ़ता ही हूँ मैं। एज अ प्रूफ ऑफ वर्क बस इसको रखना चाहता हूँ, इन केस कभी मुझसे जो है, खैर वो तुम्हें क्यों बताऊंगा।